Look, if you're trying to run AI at any kind of scale, you already know the costs are just staggering. It's a huge problem, one that can literally sink a startup. But what if you could slash those costs by 90%? Today, we're going to walk through a blueprint that shows you exactly how to do that.
Okay, so here's how we're going to break this down. First, we'll tackle the AI cost crisis head-on. Then, we'll get into the core memory fix, which is where we stop the bleeding. After that, we'll build out the specialization stack for crazy efficiency, and we'll wrap up with the pretty provocative lazy tax debate.
All right, first things first. We have to talk about the financial black hole at the heart of modern AI. Right now, there are three fundamental problems with how we run these massive models that are making the whole thing financially unsustainable.
Let's not beat around the bush here. The standard way we do AI inference today, it's like trying to air condition a server farm by leaving all the windows open in the middle of summer. We're paying for all this incredible power, but just wasting so much of it through pure inefficiency. The system is literally designed to burn cash.
So the first big problem, you can think of it as memory amnesia. Every single time a user sends a query about a document, the model reads and processes that entire document from scratch. It's like it has zero short-term memory. It forgets the work it just did a second ago and does the exact same expensive work over and over and over again.
And then you've got this fragmentation problem. Seriously, it's like you're playing the worst game of Tetris ever. You've paid for this huge, expensive GPU with all this memory, but because the data blocks are all different sizes, you can't pack them in tightly. You end up with all these empty gaps, just wasted space that you're paying for but can't use.
And finally, wrapping up our three big problems is the one model trap. This one is brutal. Let's say your app needs to understand legal docs, write code, and do customer service chats. The old way says you have to run a completely separate, gigantic 70 billion parameter model for each one of those tasks. That means 50 tasks, 50 models, and 50 times the hardware bill. It's just not sustainable.
So what's the bottom line here? When you add it all up, especially that messy fragmentation, you're looking at maybe 60% effective use of your GPU's video RAM. That means a full 40% of the most expensive part of your whole setup is just sitting there, doing nothing. It's gone, wasted.
Okay, so that's the problem. It's a mess. But how do we actually fix it? Well, this is where the architecture starts to get really, really smart. We're going to start at the foundation, with two technologies that attack that memory waste right at the source.
So the very first piece of our solution is this awesome inference engine called vLLM. It was designed to do one thing perfectly, win that terrible game of Tetris we were just talking about, the one we were losing with our GPU memory.
And how does it do it? With this brilliant idea called PagedAttention. The easiest way to think about it is like virtual memory for your computer's CPU, but on the GPU. Instead of needing one giant perfect block of space, which is almost impossible to find, it chops the data up into these little uniform pages. This lets it tuck them into any open slot, filling every single gap and making sure not a single drop of VRAM goes to waste.
And the results? I mean, just look at this. This isn't a small improvement. By just being smarter about memory, vLLM gets you a 24 times increase in throughput. 24! On the exact same hardware. That's a huge deal.
Okay, so vLLM totally solves the space problem. But what about the time problem? You know, that whole amnesia thing where it keeps redoing work? That's where LMCache steps in. You can think of it as the shared brain for your entire GPU cluster. It remembers things so the individual models don't have to.
And check out how this works. It's so clever. User A comes along and asks about some big report. LMCache does the work once and saves the model's brain state. That's the KV cache. Now, here comes user B, maybe on a totally different machine, asking about the exact same report. LMCache just zaps that saved state right over. Boom. Zero recomputation needed.
And what does this mean for the person actually using your product? A massive speed boost. We're talking 7 to 10 times faster time to first token. That's the time it takes for that first word to appear on their screen. From their perspective, it basically feels instant.
All right, so we've patched the foundation, we've fixed the memory leaks, now we can start building the really cool stuff on top. This next layer is all about getting that super specialized expert-level AI without the insane expert-level cost.
So here's how we escape that one model trap.
On the left, you see the old way, right? 50 tasks means 50 giant models, 50 GPUs, just a financial nightmare. But the new way, you run one base model, just one. And then for each special task, you just load up these tiny little adapter files called a LoRa. They just click into place, kind of like a plug-in, and give the main model its new superpower.
And this is the mind-blowing part. It means you can serve literally thousands of different expert models, but you're only using the RAM and paying for the hardware of a single model. It completely breaks the link between having more specialized skills and needing more hardware. It's a total game changer. Okay, and for the grand finale, the piece that ties this whole money-saving machine together, it's called SkyPilot. The easiest way to think about it is like a super smart, automated stockbroker for your cloud compute, always hunting for the absolute best deal on the market.
SkyPilot's job is pretty simple. It's constantly scanning AWS, Azure, GCP, even places like Lambda Labs, looking for the cheapest GPU it can find, right now. It'll automatically grab those cheap spot instances whenever they pop up. And, this is so crucial, when nobody's using your service, it scales your entire cluster down to 0. You literally only pay for what you use down to the second.
So you take all these layers, vLLM, LMCache, multi-LoRa, and SkyPilot, and you put them together into this unbelievably efficient stack. And that brings us to a pretty provocative conclusion from the source material we're looking at today.
The argument goes like this. Using big, off-the-shelf platforms like AWS SageMaker or OpenAI Enterprise, it's like paying a lazy tax. You're paying a huge premium just for the convenience. The core idea is that if you aren't managing your own KV cache and optimizing your stack, you are literally just burning money, period.
And that really is the question this whole architecture leaves us with, isn't it? Are you paying the lazy tax? Are those big, easy-to-use platforms just hiding massive inefficiencies that you're the one footing the bill for? It's the critical question every engineer has to think about as they build out their AI systems.